Hello everyone. Today we will present the topic of email encryption. Email is widely used as a communication tool in our daily life, especially in the working scenario. Statista, a German online portal for statistics, illustrates that there are roughly 4 billion email users and approximately 300 billion emails were sent and received per day in 2018. Therefore, it is quite essential to encrypt the entire content and attachments so that only the recipients could receive and read the emails to ensure their integrity and privacy. Without encryption, email communication might be a disaster, and the detail of emails could be easily hacked by the malicious. In this presentation, two major end-to-end encryption techniques will be respectively illustrated in the first two sections. They are pretty good privacy and secure multi-purpose Internet mail extension. Besides, example and comparison will be done in the last section.
First, let's start with PGP. Pretty Good Privacy is an end-to-end program implemented in email transition field. It was developed by Philip Zimmermann in 1991 and has become a common standard for email security. It normally holds two services. One is encryption and decryption of emails, which prevents the data from eavesdropping, and another is digital signature. Digital signature makes sure the authenticity and integrity of the email's content. PGP is a hybrid approach that combines hashing, symmetric key cryptography, and public key cryptography. Data compression can also be applied in the PGP program, which saves the transmission time and the disk space, as well as strengthens the security. As mentioned previously, encryption is one of the main services of PGP. The following charts explain the process of encrypting email content. Data compression is normally done in the first step before the encryption. The hackers who would like to steal the message may have some trouble in understanding compressed information. PGP then generates a one-time section key and encrypts the original or compressed message with that section key. After that, this key would also be encrypted with the receiver's public key. Both of the encrypted key and message will be sent to the receiver. Once the receiver got these two things, he will do the decryption step in reverse order. For example, he would use his private key to get the section key first. The next slides introduce the digital signature service. Digital signature as another service of PGP works with the hash function. The sender first uses a hash function to compute a hash from the original message, and then generates a digital signature from that hash by providing the sender's private key. ISA or DSA algorithms are implemented in this step. Further, the signature was sent to the receiver with the original message. When the receiver retrieves the hash with the public key of the sender and calculates the hash of the message, these two messages should match each other, which makes sure the authenticity. Data compression can be applied to strengthen the security in this service as well, which are normally applied after the digital signature.
Let's move on to the SMI. SMI stands for Secure Multipurpose Internet Mail Extension, which is regarded as the most widely used cryptographic technique for email encryption. So in this section, I will introduce the concept of SMI, followed by its procedures and functionalities. To understand SMI, we need to explain the conception of MI first, which is the underlying email format SMI applies. MI is the standard way used for expanding the limited abilities of email. It's the first non-ASCII format of attachment in email, and it's implemented by adding defined 5 header fields to the original message header lines, which are MI version, content type, content transfer encoding, content ID, and content description. So MI supports for varying content types and multi-part messages. During the process of sending an email, the attachment is likely to be modified, which means the confidentiality and integrity are not guaranteed. Therefore, the SMI is proposed to enhance the security of MI by providing more security features or services. These services are based on hierarchical certification infrastructure, public key infrastructure, which is used to verify the certificates. That is, users or senders are required to obtain their public key and certificates from the certification authority. These certificates are being used to generate protected MI messages. More details will be clarified in the following section, Procedures. The procedures of SMI consist of two components. When using SMI certificate to sign email, a digital signature is generated by a private key and appended to the message. The public key used for authenticating the signature is also contained in a protected email. Then, the content of message is encrypted by using the receiver's public key and decrypted by using the receiver's corresponding private key. And the receiver's user's public key comes with a certificate to verify the identity of the sender. The digital signed and encrypted email prevents the message from being modified by attackers. Keep the email secure until the intended receiver reads the message, and help the receiver to be sure that the sender is the expected one instead of someone else. Let's move on to the functionality of SMI. As we all know, SMI allows to digitally sign and encrypt emails. In more detail, the following functionalities are offered by SMI based on different content types. The signed data is used to provide authentication and ensure non-repudiation of the sender, while enveloped data providing privacy for the message. Clear signed data also provide authentication for users, and message integrity can be verified using message digest. So we can say SMI makes authentication, integrity, non-repudiation, and privacy services available.
Now, let's move on to the last section. Here is an example of sending secure emails with SMM. First, I got a free SMM certificate from Actalis and added to the keychain. The hash function is SHA-1 and the encryption algorithm is RSA. The first email sent to a new receiver cannot be encrypted yet because the receiver's public key is unknown. After sending a signed email to each other, the mail application will automatically store the public keys, and now we can send encrypted emails. As shown in the screenshot, the first two emails are only signed, and the last email is both signed and encrypted. Here is part of the raw source of the encrypted email. The original short plaintext is already encrypted to a long ciphertext. To summarize, both PGP and SMM use public key cryptography, but they differ in several aspects. The main difference is independency. SMM depends on a centralized, trusted authority, and this takes away the burden of verifying public keys from the users. As for PGP, it is based on Web of Trust model. No intervention of any third party is needed. Every user can generate and distribute the key himself. Another difference is the scope of protection. PGP is developed to address the security issue of plain text messages, but SMM is designed to secure all kinds of attachments. The last one is compatibility. PGP is more complicated for users because it requires additional plugins or downloads to operate. SMM is much easier to use as most email clients come with built-in SMM support. And that's it. Thanks for watching.